You hope all are doing good. Okay, so let me take up a question where a parallelogram is given to you. The three sides PQ, DC, and AB are parallel to each other. Where, let us say, this is PQ given to you. Let me zoom a little. Is it visible? Yes. So let us say this is PQ, right? And this is parallel to DC. DC is little longer than PQ, like this, and after that AB, which is the longer from DC and PQ, right? So this is DC and this is AB. So in this question it's given that PQ parallel to DC parallel to AB. PQ parallel to DC parallel to AB. This is given to you, right? And we have some transversals which are connecting these sides of the parallelogram. That means ADP is connected like this. Similarly, QCB is connected like this, right? So into this question, it's given that all these three lines PQ, DC, and AB are parallel to each other, right? Now, from here, these lines are also connected. Which lines? I am showing you. Okay, the lines which are just connecting are these diagonals DQ and PC are connected with each other. This is connected, right? Similarly, this PC is also connected. This PC is also connected. Similarly, AC, this AC is connected. That means the diagonal of the parallelogram ABCD is connected. Similarly, BD, the another diagonal, this is connected like this, right? Now, into this diagram, it's given that PQ parallel to DC parallel to AB. That means all these three sides are parallel to each other, right? Now, we need to prove that area of triangle ACD and BCD are equal. ACD, to prove area of triangle ACD is equal to area of triangle BCD, right? What is ACD? ACD is this triangle, this one. This is ACD and BCD is the triangle BDC, this one. So my dear friends, if you remember, the triangles on the same base and between the same parallels are equal in area, right? So here ACD and BCD, that means ACD and BCD are on the same base DC or CD, right? And between the same parallel CD and AB, my dear friends, right? So in this case, area of the triangle ACD, which I have shown into the shaded color, right? This should be equal to area of the triangle BCD, right? Hi Sincha movie, hello bro. So this will be equal. So we can say that area of triangle ACD will be equal to area of triangle BCD, right? Now from here we can see that yes, triangles on the same base and between the same parallels, right? So what we need to prove is proved, right? What are the theorem which we have used? The theorem which we have used is that triangles on the triangles on same base, right, on the same base and between same, let me write parallels properly, same parallels or same parallel lines are equal, equal in area, are equal, right? So my dear friends, from here we can see that yes, now ACD and BCD are equal, which we are about to prove, and this is proved, my dear friends, right? Now, the second part of the question is that, so in proving this, we have seen CD and AB are parallel, and CD will be the acting base. If you are just hiding this, okay, you can see if CD is the base, on the same base, this triangle ACD is built up, right? Isn't it? Just see from this side, see from this side, right? If you see from this side, CD will be the base, and this ACD and BCD, both triangles are having the same base, right, or having the same base. Therefore the area of these two triangles will be equal. Using this theorem, triangles on the same base and between the same parallel lines are equal in area, right, are equal in area, right? So in this way we have proved this one, right? Now take the second one. What is that? The second one is that triangle DCP and DCQ. So my dear friends, DCP, this is the second part. Area of triangle DCP is equal to area of triangle DCQ. This we need to prove. DCP is equal to DCQ, right? So, hi Kiran, hello, how are you, my dear friend? Good evening. So, DCP and DCQ. Where is DCP? DCP is this triangle, right? You can see here DCP, this one, which I have just shaded into the orange color, right? So from here we can see this DCP, as I have highlighted into the orange color. This is on the same base DC, right? And if you see the DCQ, right, DCQ, so from here DCQ, you can see DC is the same base, this base will be same DC, and you can see PQ and CD are parallel lines, and both of these triangles are lying between the same parallel. So again the same theory will be valid. Triangles on the same base between the same parallels are equal in area, right? So hello, how are you, my dear friends? Hope you all are doing good. So using the same principle, same theorem, we can say that yes, DCP is also equal to DCQ. That means area of triangle DCP is equal to area of triangle DCQ, right? Now, this is also proved, my dear friends. This is also proved, right? So I'm just explaining how these areas are equal, right? Using the figure, right? Now go to the third part. The third part of the question, which was about to be proved, is that area of triangle ACP equal to BDQ. So area of triangle ACP is equal to area of triangle BDQ. This is about to prove. This need to be proved, right? B, D and Q, BDQ and ACP. First of all, locate this ACP into this triangle. Where is ACP? ACP. So my dear friends, ACP is the total shaded area. the blue area and the orange area, right? That means we can say that ACP is the sum of ACD, this one, and DCP, DCP, this one. So if you just add the LHS of both the proved part, right? What we have proved, that is ACD is equal to area of triangle BCD. Then let me write area of triangle ACD is already proven as equal to area of BCD, area of triangle BCD. This we have already proved, this part, right? So from here we can say, hello Kiran. So from here we can see, hi Susma, hello, good evening all my dear friends. So you can see we have proved ACD is equal to BCD as triangles on the same base and between the same parallel, right? So from here we can say yes, this area is already proved as equal. And from the second one, area of triangle DCP is equal to DCQ. Where is DCP? The orange shaded, right? I'm writing it again. Why I'm writing it, I will explain you. So area of triangle is equal to area of triangle what? DCP and DCQ. So I'm writing DCP and DCQ. Okay. So what is the benefit of writing like this? Benefit of writing like this is that when you just add it, what you will get? Just add the LHS and add the RHS. Okay. So here just add it, the LHS and the RHS. Then you will get ACD and DCP. ACD and DCP. This will give you the triangle ACP, this one, isn't it? Right? This will be equal to, let me change the color of my pen so that it can be easily visible, my dear friends. Right? So from here, let me write simply using blue pen. That is area of triangle ACP. ACP. Right? That means this one, the blue one and the orange one. Both of these taken together. Right? So ACD and DCP will be forming ACP. Isn't it? The complete shaded one. Right? Hi Sujata, I will make a Discord channel so that people can ask their question from you and you will get more rich in content as well. Thank you Sujata. I will take up your suggestion. Thank you for being connected and giving a good suggestion. Okay. So in this way, my dear friends, we can see triangle ACP, which is into the LHS, will be equal to the RHS, that is BCD and DCQ, which is already proved as equal to the green and orange. Okay. So what is BCD and DCQ? BCD is this triangle, right? BCD, right? And DCQ is this triangle, right? So that means the triangle, this one, I am just shading it. Okay. The green one will be equal. The green one, this is this is the triangle BDQ. BDQ. So from here you can see the RHS, both the triangles will add up and it will give you BDQ, right? So my dear friends, all of both these will add up and give you this triangle, right? Will give you this triangle. So in this way we have proved that area of triangle ACP is equal to area of triangle BDQ, right? Both are equal, right? Both the areas of ACP is equal to area of triangle BDQ, right? So, my dear friends, in this way we can easily solve this question. Okay, it's very easy because you need to understand the concept that triangles on the same base between the same parallels, the theorem which we have used the same theorem to prove the 1, 2 and 3, all the parts of this question, and we have proved ACD is equal to BCD. We have proved DC area of triangle DCP is equal to a DCQ. Okay, you can just refer the details into the question, right? Now from here we can see that this is proved, right? Now from here we can move forward, right? Let me give a little, give me time please. So in this way we have proved this. So I can see little ghost. Hi little ghost. Hi. BPT theorem explain please. Okay. BPT theorem is basically, it's a basic proportionality theorem, my dear friend. Okay. Your name is so, why you have written ghost in your name I don't know, but yes, it's a good name, and the ghost is little. Okay. Okay. On the lighter note, don't worry. So BPT is basically the basic proportionality theorem. So if a line which is drawn parallel to the, if a line which is drawn parallel to one of the side of a triangle, right? If any side, then it divides the other two sides at certain points, right? You want me to draw? Let me draw it. What BPT says, that if a triangle is given to you, so if a line is drawn parallel to one of the side, it can be this side or this side. Let us say the line, the triangle is ABC and the line AB is considered, and a line is drawn parallel to AB. Let us say this line. You can see both of these are parallel to each other, right? And this parallel line is intersecting AC at, let's say, P, and this parallel line, the same parallel line is intersecting CB at Q, right? So my dear friend little ghost, here this BPT says, by BPT, that means basic proportionality theorem of a triangle, shows that the ratio of this one, that means CP to AP, will be equal to CQ to QB, right? That means the ratio in which this third line, or the line PQ which is drawn parallel to the third side, it will just divide the other two sides of the triangle into the same ratio. This is the BPT, my dear friend. Okay, so from here we can write, if PQ is drawn parallel to AB, the third side of the triangle, then from here, my dear friend little ghost, basic proportionality theorem says the ratio of CP to AP, right, is equal to, hi Kiran Yadav, hello. So CP to AP is equal to CQ by QB, right? This is basic proportionality theorem. That means this parallel line divides the two sides which is not, whose, the parallel to which is not considered but parallel to the third side is considered. Then this line PQ, which is parallel to the third side of this triangle ABC, divides the other two sides, not this one, into the same ratio. That means CP, this CP to AP is equal to CQ to this CQ to QB, right? This is basic proportionality theorem, right, my dear friend? I hope you got some idea. We can take many questions. Okay, there can be a question over here that prove that if CP to AP, right, here is given, that then it can be proved, it can be asked that then prove that CP by AB, sorry, CP by AC is equal to CQ by BC, right? So if such question will come to you, you already know that by BPT CP by AP equal to CQ by QB, right? Then you can add this corresponding part AP and QB here into the numerator, which are equal to each other. Okay, the ratio will be same. Then we can say that yes, this ratio will also be equal, right? So in this way we can take such questions, right? So my dear friend, I think we can close this, and today is a very good day because India won the cricket match and many of us are lover of the good game. Okay, so thank you so much for watching, my dear friends. Be connected, take care, happy learning, bye bye, see you. So let me show the background how I'm writing. This is the entire page in front of you. Okay, this is the notebook where I have just solved it. Okay, we have just explained the basic proportionality theorem as asked by little ghost 1234, right? Now I think we can close this session, my dear friends. All the very best, take care, good night, see you again into my next class. Thanks for being connected. Take care, my dear friend, bye bye.